Okay, now we are looking at the last section of Chapter 5. What limits the growth of populations? So the concept is no population can grow indefinitely because of limitations on resources and because of competition among species for these resources. Okay. And then most populations, they live in clumps. So first, make sure you understand the definition of a population. Those are groups of interbreeding individuals, which means groups of the same species. Okay, they live in the same area. If they are not living in the same area, they are not able to do interbreeding, right? And then population distribution, and then many of them, they live in clumps. So what are the advantages of clumping? So some of the advantages are good to themselves. Some of the advantages good to their predator. But either one, that would be good for the ecosystem. Okay. The two advantages good for the population itself is the species cluster for resources. So if one found a resource, then all of the individuals in the cluster can enjoy that. And then they also can help each other protection from predators. If one discovered a predator, they can warn all the individuals run away. But on the other hand, something good for the predator is if they are caught by a predator, the predator can have a good meal because you not only get one individual, you get a group. Okay. And then, so population size. So what are the factors impact the population size? So overall, we can think of that. So it's birth and death, and immigration and emigration. So if you write them into an equation, you would say population change equals birth plus immigration and then minus death and emigration. Okay. And then if you look at the structure of a population, you can put them into three groups. One is pre-productive age, one is reproductive age, and then the other one is post-reproductive age. Just to know the terms for now, and then next chapter, chapter 6, we're going to learn more about the significance of each age group and how they contribute to the population growth. And then if you look at the population growth, and then some factors impact their birth, impact their death, and then impact how much immigrated individuals can live there. Okay. And then one thing we have to introduce or a review is range of tolerance. Okay. Recall we did water testing. We mentioned why the water quality at a certain level, why they are important, right? So variations in physical and chemical environment. There's always variations. And then the individuals or of different populations, they might have different tolerance ranges. Remember a bell curve. So there is a principle is called limiting factor principle. So too much or too little of any physical or chemical factor can limit or prevent growth of a population, even if all other factors are at or near the optimal range of tolerance. So for example, if you have everything is great, except nutrients are not good, and the nutrients become the limiting factor for the population growing. Or you have a precipitation, you have nutrients, you have everything. However, and then you don't have sunlight, and then that sunlight would be a limiting factor for that plant to grow. Okay. And then population density, I believe you guys know. Okay, here is the tolerance range, a graph. So you always have a bell curve. This bell curve can be very wide or can be very narrow, depends on. If you are a generalist, then your bell curve is big. If you are a specialist like a panda, and then your tolerance curve is very sharp. So in the best part, you have abundance of the species. And then when a little bit too high or too low, and then you have less individuals growing there. And then when you get out of their tolerance zone, you call them intolerance zone. And then none of the species is able to grow. And then one part which is not in our book, you need to pay attention, is reproductive strategy. So roughly we can put them into two categories. Obviously, there's some of the species in between. Okay, so some species, they go through the R reproductive strategy. So this one is they have many small offspring, and then they have little parental involvement, parental care. Such as one example is the dandelions. They produce millions of seed, and then where they go, they don't care. Okay, other species is called K reproductive strategy. So this one is the individual would reproduce later in life, and then they produce very little number of offspring, and then they have great parental care. And then if we look at population growth, there are always limits to population growth in nature, always. Okay, and then they have something called environmental resistance. So the factors that limit population growth in certain time. If you are at a dry season, then precipitation would be the environmental resistance. If you are in the cold area, then in the winter, the harsh temperature will become an environmental resistance. Okay, and then a definition you needed to know is called carrying capacity. So this one is the maximum population of a given species that a particular habitat, a particular environment can sustain that population forever, indefinitely. Okay. And then if you look at the population growing and then make them into a curve, you would see two kinds. Okay, one is called exponential growth. It's also called J-curve growth. So this one has a fixed percentage per year. If they grow 2%, they keep going. 2%, 2%, keep going. And then the other one is called logistic growth. So this one kind of is a S curve. So population faces environmental resistance, so growth rate declines or maintain the same as a death rate and birth rate become equal. They stabilize. So here is a diagram to show you these two concepts. So when this population comes here, settle down, all the environment favor their growth. So they grow rapidly with a fixed annual growth rate. And then this part is pretty much looks like a letter J, right? This is J-shaped growing. And then eventually, this one is called overshoots because the environment condition are able to support them. So the population crash. And then gradually they just level between the capacity of their overshoot and then come back. So eventually the population becomes stabilized. Why they become stabilized is because of environmental resistance. One of them is the food supply. Okay. So this part of growing, and then we call this one logistic growth. So one part in the middle of section 5 is a part mentioning why is the recovery of southern sea otters a slow process. This is one of your questions. Okay, so female sea otters reach sexual maturity between 2 and 5 years of age, can produce until age 15, and typically each produce only one pup a year. So this one is a K reproductive strategy. A rise in population of orcas, which is a killer whales, they feed on them. And then people think about it because their other prey die out. So they prey more on sea otter. And then some southern sea otter may be dying from cat parasites contained in the feces-laden cat litter in the coastal water area. And then otters are also being threatened by blooms of toxic algae bloom due to eutrophication. All those factors cause the sea otter to recover slowly, although they have been protected for several years. On the other hand, the white-tailed deer population exploded. Okay, so a while ago, their habitats got destructed. So, and then the uncontrolled hunting, their population really went down. And then there's laws to protect them. And then right now, the population exploded. They cause a lot of trouble. So they spread Lyme disease, and then they also cause a car accident. They kill way more than bear and then shark. And then they invade people's garden. So when you read the book, you would see there's several ways we try to control the deer population. And then when a population exceeds its carrying capacity, it can crash. Because if you destroy your own environment, then how you would be able to sustain, right? So a population exceeds the area's carrying capacity, and then their reproductive time lag may lead to overshoot. They didn't realize, so they're still producing offspring, and then eventually got a population crash. And then damage may reduce the area's carrying capacity if the environment is in a type of inertia. And then once they are damaged, they are not able to recover back. But if the environment is of the sort of resilience, like a grassland, maybe they can come back quicker. Okay, so this is one example. A population grow rapidly, J-shape, and then overshoot over the carrying capacity, and then crashed. So this would take a while for the environment to recover. And then this one is not only happened to other animals, human beings are not the exception, okay? So over history in Ireland, they had a problem with potato. So potato crops in 1845, so Ireland experienced such a crash after a fungus destroyed its potato crop. And then about 1 million people died from hunger or disease related to malnutrition. And 3 million people migrated to other countries. American probably is the biggest receiver. And also there was a disease, it's a bubonic plague, happening in the 14th century, mostly in the European area. And they also have AIDS. And also probably years later, the COVID-19 would be in the textbook too. So the big ideas of this chapter is certain interactions among species affect their use of resources and their population size. Remember resource partitioning. And then changes in environmental conditions. This one would cause the communities and ecosystems to gradually alter their species composition. So this is ecological succession. Remember there's two kinds, primary and secondary. And there is always limits to population growth in nature. Okay, I'm going to stop there. Thank you for watching. Hope you do well on the test and quiz.